Hello, during today's video we're going to be talking about mass percent. Now we've already dealt with mass percents before, but now we're going to actually be able to use this idea of the mole and conversions between grams and moles and grams to figure out the mass percent. So everything that we've done before, all of those examples that I came up with to give you and that you've worked, I came up with those using the method that we're going to be solving for here. So let's take an example. Let's just quickly go through an example, see how this works. So let's say we have 88.02 grams of carbon dioxide. And we want to know the mass percent of carbon. Mass percent of carbon. We know that the mass percent of carbon is going to be the mass of carbon divided by the mass of carbon dioxide. Mass of carbon dioxide, all multiplied by 100%. So this is the equation for mass percent. It's the mass of the element divided by the mass of the sample times 100%. That gives you the mass percent of that element. Now, we were given the starting amount of carbon dioxide. What we need to do is figure out the mass of this individual element in here. So we have to do a few conversion steps to get to the mass of carbon. So what we can do is, we know as a chemist that we like the grams, the unit of grams, because we can weigh them out downstairs in the laboratory. However, moles are much more important to us as a chemist. We can convert a lot more different ways using the mole rather than grams. So let's take these 88.02 grams of carbon dioxide and convert it into grams of carbon. And the way we do that is, first we divide by the molar mass of carbon dioxide, which is 44.01 grams of carbon dioxide for every 1 mole of carbon dioxide. Here we've canceled out the units of grams of carbon dioxide. We're now into moles of carbon dioxide. Well, now from here we can use the subscripts to identify the mole-to-mole conversion from the entire compound to the individual element. And since we're looking for carbon, we're going to convert into carbon. So for every 1 mole of carbon dioxide, there's 1 mole of carbon. Our moles of carbon dioxide cancel, now we're into moles of carbon. The last step, since we're trying to look for the mass of carbon, is to convert from moles of carbon to grams of carbon. We do that by multiplying by the atomic mass of carbon. So for every 1 mole of carbon, there's 12.01 grams of carbon. The moles of carbon cancel, we're now left with grams of carbon. If you plug this into a calculator, you end up getting 24.02 grams of carbon. So now we know how many grams of carbon are in 88.02 grams of carbon dioxide. For every 88.02 grams of carbon dioxide, there are 24.02 grams of carbon. Now we have everything that we need to calculate the mass percent of carbon. We have the mass of carbon, which we calculated as 24.02 grams of carbon. We have the mass of carbon dioxide that was given to us at the start of the problem, which is 88.02 grams of carbon dioxide. And we have the 100%, it's just a number, times 100%. If you plug this into a calculator, and keeping 4 significant figures, you're going to end up with 27.29% is the mass percent of carbon. Okay. So for every 88.02 grams of carbon dioxide, the carbon has a mass percent of 27.29%. Now, we've seen previously in the class that mass percents can be used in a lot of different ways, and now we have another way of solving for mass percent. So the great thing about mass percents is it doesn't matter if I have 88.02 grams of carbon dioxide, 14 grams of carbon dioxide, 1 gram of carbon dioxide. Any carbon dioxide will have a 27.29% mass percent of carbon. That will be for every sample of carbon dioxide. So we're going to be doing a lot of problems like this in class just to get you aware of how we can use mass percents. It is a very popular technique in the world of general chemistry, so we want to make sure that we understand how to do this as effectively as possible. So with that, I want to say have a great night. I will see you all in class tomorrow.